All right, today I wanted to take a look at 27, which is fundraising. This is on page 111. This is another application of linear inequalities. All right, so if we take a look here, it says that the band boosters want to open a craft bazaar to raise money for new uniforms. 2 sites are available. A main street site costs $10 per square foot. The other site on High Street costs $20 per square foot per month. Both sites require a minimum rental of 20 square feet. The main street site has a potential for 30 customers per square foot. Okay, so what that's saying is you can fit 30 people per square foot, while High Street site could see 40 customers per square foot. The budget for rental space is $1,200 per month. The band boosters are studying their options for renting space on both sides. And of course, we want to do the polygonal convex. We want to get that region. We want to look for maximums and minimums to see what we can come up with. All right, so let me get rid of this. All right, this is done. All right, so now let me change pens here so we can write a little bit. All right, so now if we check this out, let's go up here to the top. I already did one of the graphs, and I'll show you why here in a minute. But basically, we want this to be, I don't like that color. Let me change this. All right. Let's go, let's let X represent Main Street. So this will be Main. Okay. This, of course, will be street. And, of course, let's let Y equal High Street. All right. Now, if you remember back to the problem, there's a couple things we need to look at. We need to look at X has got to be greater than or equal to 20, and Y has to be greater than or equal to 20 as well, because they're saying that the minimum rental is 20 square feet. All right, and of course, if we want to look at the cost, you know it's going to cost $10 at High Street, plus we can add $20 for the for High Street. Okay, which is Y. And we know that we only have this much money to spend, so this will be less than or equal to $1,200. Okay, so if you notice here, we have 1, 2, 3 inequalities. Now, if we look at the cost, okay, if we look at the number of customers, we know that F of XY, now this is going to be customers per square foot. The first location, we're going to be able to house 30 people per square foot. Plus the second location is going to be 40 per square foot. And I'm going to squeeze a Y in there. All right, so this is our function that we need to deal with at the end. Okay, so now we have 3. So here's 1, 2, 3 inequalities. Now if you notice this first one, the last one, if we solve this for Y, this becomes Y is less than or equal to, let's put a negative in here, and this is going to be X, and of course this will be negative 1/2 X, and this will be plus 60. Alright, so what I'm going to do is go ahead and graph that. You notice that the y-intercept here is 60, so let's go up to 60 and make a dot. Okay, so the dot right here, and you go down 1 over 2, down 1 over 2, and of course, so this point right in here, right here, is going to be 0, 60. Okay, this point down here, lower right, down in here, is going to be 120, 0. Okay, so let me erase all this. I'll come right back. Well, before I do that, let me do this. Let's change this color here to this. Now notice one of the other inequalities is y is greater than or equal to 20, which is here. So let me draw that one in. So it's going to look like this. And then x is going to be greater than or equal to 20, which is going to look like this. Okay? And of course now we're dealing with this area in here. Alright? Okay, so let me clear some of this up. I'll be right back. Alright, so now what we know is that we have a line in here that represents 20, and we have another line in here that represents 20. So what do we form in here? If you notice, I'm going to change this to my marker. I'm going to stick with yellow. So now let's go in here and let's shade all this. So everywhere inside here is going to be a solution area. Okay, so everything gets satisfied all at the same time when we do that. Okay, let me go back to my pen. So now if we could determine this point, which is pretty easy, we know this is going to be 20, comma 20. Okay, and graphically we know that this point right here, okay, this point right in here, I don't know why it keeps doing that, this point right in here is going to be, if we look at it graphically, we know that this line is 20, so x is going to equal 20, and it sure does look that y equals 50 in here. So that's point number 2. And then down here at the very end, if we look at this graphically, we know that that looks like 80, okay, and of course y in that case is going to equal 20. So there's our 3 points of interest: 2020, 2050, and 80-20. If we can determine the min and max for that, would be great. All right. So what I'm going to do is go over here to the left, and let's make this. Let's go with a nice blue. So now this is going to be f of xy, and we know this is going to equal 30 people per square foot at Main Street, plus we can do 40 people at High Street. Let's figure out what combination gives us the most people. Alright, so now let's do this. First one is going to be f of, let's go 2020. So this is going to be 30 times 20. 30 times 20, of course, gives us 600. Of course, this is going to be 40 times 20, which is going to give us 800. So, of course, this equals 1,400. Okay, that's one value. All right, second value is going to be in here. Let's do f of 2050. All right, f of 2050 is going to give me 30 times 20, which is 600, plus 40 times 50, which is going to be 2,000. And this, of course, gives us 2,600. Okay. And then the last one here is going to be 80-20. 80-20, of course, 80 times 30 is going to be 2,400. And then let's add 20 times 40 is going to give us 800. So our total in here is going to be, all right, so if we take 2,400 plus 800, of course, here we get 3,200. Yeah, I think that looks right. Yep, 3,200. So if you notice, our maximum values here are going to be 80 square foot at Main Street, 20 square foot at High Street, and that'll give us our maximum capacity. All right. Hope this helps. Again, this is number 27. This is an example of 3 inequalities, and we're finding a maximum value, and of course the maximum again occurs at 80-20. 80-20. Thanks, and have a great day, and you're more than welcome to watch this on YouTube.